Hey everybody, welcome back. In today's deck, we're going to dive right in and show you how unit vectors can help make your vector life easier, simpler to deal with, and more accurate. So to begin with, here are two unit vectors. So force 1 is 10 newtons in the I direction and negative 12 newtons in the J direction. Quick recap, the way that would look if we drew it out would be here would be the 10 newtons in the I direction, and here would be minus 12. You notice I put them together tip to tail. In the J direction, so that immediately means that force 1 is actually, if I can combine it, drawing a straight line is a little hard, but you get the idea. So here would be force 1. It's this guy right here, force 1 at this angle here. And then force 2, minus 4i, he'd be out here, minus 4i plus 22j, great big long line going upward. And then that vector would be some kind of big thing that points in the second quadrant, mostly vertical. There we go. Not pretty, but there we go, getting the job done. And it would be at this angle right here, so a little bit more than 90, and we'd somehow have to add them. We don't want to do it that way. You can make a law of the cosines problem out of this thing. You certainly can, but why would you? Here's really why we like unit vectors. Because if we can get vectors into the unit vector form, to combine them, all we literally have to do is treat this like it's a simple sum. So you just draw a plus sign, you draw a line below them, and you add the i's with the i's. That gives me 6i. And you add the j's with the j's, and I get plus 10j. And then all I need to do to figure out the answer to this addition problem is either leave this the way it is if they say report your answer in unit vector form, where you would say, yes, oh my God, I'm done. Or if they made you report the result in polar form, that's still not that bad, because we've got now a simple right triangle, and we're right back in the land of physics 1, where I would draw the long one first. So for me, I would draw the 10j first, and here's 10 newtons in the j direction. And then out of the top of that, I would draw 6 newtons in the I direction. So I've got the I and the j represented. The vector answer for this would be r, and all we'd have to do would be to go through the usual process that we did before. So Pythagorean theorem is going to tell us that r squared equals 6 squared plus 10 squared. So r equals the square root of 164. Okay, and we figured that out. And so the square root of 164 is 12.8. So r would be 12.8 newtons. Then we would go and figure out the interior angle here, theta. And that's going to be theta equals tangent to the minus 1 of 6 over 10. We're losing the thread there a little bit. So inverse tangent of 6 over 10. Let's go grab that guy. And that comes out to be 30.96. We'll call that 31 degrees. And then we would have finally said our overall answer is 12.8 newtons at, and the answer angle is going to be this one right here. So we are going up to 90, backing it off by 31 degrees, so that adds up to 59 degrees. Okay, so there you go. That's how you add vectors using unit vectors. So much simpler, so much more straightforward. Okay. Resolving vectors with unit vectors is very similar to what you learned in Physics 1, where you broke these things down into right angle components and you call them east, west, north, and south. So here we got 233 degrees, so I want to dial that up first. 233 degrees, 215 is the 45 degree angle in the third quadrant, so we're a little bit farther down towards the 270. So what I'm going to imagine then is I take my my resultant arrow, pin it down at the hub here in the origin, and spin it around to 270, and then back it off by 37. So what I'm going to do is now draw my vector, and I drew it this way because, as I have mentioned in a previous deck, what I always try to do when I'm resolving vectors is draw them so that I have an acute angle, angle less than 45, on the inside of the angle. And it makes it easier to draw this because the act of drawing the components is a little bit harder than adding them together, because really what I have to do with my brain is supply two sides of the triangle. So this makes it easier. So what I want to do is draw this component right here, the downward component, so that it matches up laterally, or up and down rather, vertically with this one. And then I'm going to draw the second component over here so that I have this component going down, this component going across to the west, fitting together like one-way streets, and they both make up this 5 Newton resultant. Okay, so what I'm going to do, this I'm going to call, this is a force, so this is going to be my force Y. This is now my force X, and we'll use trig to go and figure those out. So F, let's just write it out the old school. Let's start with sine. So sine of 37 degrees equals opposite over 5, and opposite is Fx in this situation, over 5. And so what that does is it gives me Fx is 5 times the sine of 37 degrees, and that comes out to be 3, or close enough. Similarly, we've got cosine of 37 degrees equals Fy over 5, and what that gives me is that Fy equals 5 times cos of 37, and that's going to equal 4, or close to it. So here's our 3, 4, 5 triangle again. And then finally, to write this in unit vector form, super simple. I usually write the i's first. That's traditional. So this I is going to the left, so that's just going to be negative 3i. And then the j component comes next, and it's also in the negative direction, so I'll write minus 4j. And so there you have it. That is our answer. 5 newtons at 230 degrees in unit vector form is minus 3i minus 4j. Okay. Finally, what we're going to do is put all of that together by adding those two forces that we talked about. So if I have 10 newtons at 340 degrees, 5 newtons at 323 degrees, what I'm going to do is to break them down individually. So rather than get into the law of the cosine situation, I'm going to attack this one first, then I'm going to break this one down. And since we've already done the math for this, really, what I'm going to do is pause the deck here, and I'm going to write out the math that I need to do to set these up. Okay, and then we'll come right back. Okay, so we're back. So what we've done was lay out the components of our 10 Newton vector here, and we've got that the fx component is 9.4, the fy component is 3.42, and in unit vector form, we're just going to write that down as 9.4 in the positive I direction and minus 3.42 in the j direction. Okay, so that's force 1 broken down. Next thing we'll do similarly, since we did just visit with this one, you'll remember that this component in our 3, 4, 5 triangle, this is 37 degrees, looked like this. So that means force 2 we can get pretty much by just looking at it. This is going to be 4i, and it's going to be minus 3j. Okay, so we're just reusing a little bit of information from earlier in the deck. And now what we're going to do is just put that all together. So finally, to get the composite of those two vectors, you just add the components. So 9.4i and 4i adds up to 13.4i. And then minus 3.42 and minus 3 gives us negative 6.42 in the j direction. And again, if what they had said in this problem was report your answer in unit vector form, sweetest thing imaginable, you're done at this point. Oftentimes they don't. They'll want you to go through and put that in polar form, but it's a lot easier now, and the math is just straightforward right triangle math. So what we're going to do is draw a 13.4 long vector there. Here's 13.4 in the positive I. And then out of that one, we're going to draw downward a minus 6.42 vector. And then all we have to do is just get the value of this resultant vector here, the angle inside here by doing vector addition skills. So we're just going to set that up and come back and take a look at that in just a minute. Okay, so what we've done then is to work out Pythagorean theorem. So r is equal to the square root of this whole stuff right here. And we get that the length of r is 14.86. We set up our inverse tangent equals opposite over adjacent. We figure out the interior angle is 25.6. So it's all coming together. And this is like our worst case scenario problem. It's still not bad. So the answer is going to be 14.86 newtons at, and we'll squeeze it in down at the bottom here. That's going to be 360. So going all the way down to 360 minus this 25.6, which I think is 334.4 degrees. Okay, and so there you have it. Plenty more on that coming in class, lots of examples, but that's how you're going to think about it. So take care, and we'll see you soon. Bring your questions to class. Bye-bye.